Hello class, this is a video tutorial on the derivatives of inverse functions. The derivative of an inverse function can also be found using the following property. Since dy on dx multiplied by dx on dy equals 1, we can actually find the derivative dy dx by dividing dx on dy. So it becomes 1 on dx on dy. Now this property seems rather confusing at first, but you'll see through our examples how we actually might use this. So let's find the derivative of the following in terms of y and then in terms of x. You'll find it's the same three functions that we saw previously, but you'll see how we might use this property here. So let's begin. So normally we would find the derivative function. We'll switch out x and y, and then from here we would continue until we find the function of y in terms of x. So it would become y equals x minus 2, the fifth root of that. And then we would differentiate this. But we can now find dy and dx by the following. So we go dx on dy. So we differentiate this as it is. So it becomes 5y to the power of 4, and the 2 goes away. But now we can find dy on dx simply by taking the reciprocal of this. So it becomes 1 on 5y to the power of 4. So this here is the derivative of the inverse, right, in terms of y. So we've actually answered the first one here. But if we want to find it in terms of x, we simply take this expression and substitute it here. So it becomes 1 on 5, and since it's the fifth root to the power of 4, it becomes x minus 2 to the power of 4, but the fifth root of that. So as you can see, it's actually the exact same as we saw in the previous examples. Okay, so it's as simple as that. So we can find dy and dx by simply taking the reciprocal of dx on dy. Now you'll see the usefulness of this later on, but for now let's just continue with the example here. Okay, so we can find dx on dy equals 2y plus 4. To find dy on dx, we take the reciprocal of everything here. So 1 on 2y plus 4. So this here is the derivative of the reciprocal function. But if we wanted to, so this is currently in terms of y. If we wanted to, we would substitute. Well, so first we would make y the subject here and substitute that back here. From the previous video, when we made y the subject for this, we got y is equal to negative 2 plus minus x minus 1 square root. So we would substitute this back here. So it would become dy on dx equals 1 over 2 bracket negative 2 plus minus x minus 1 square root plus 4. So we would expand this and simplify, and it will be the exact same as we saw here. It would become one of these two here. Alright, so I hope that actually gets the idea. Let's keep going and let's see what we can come up with in the third example. Okay, so for the third example, we simply differentiate this. Now just to make it a little bit easier, I'll write it as y minus 3 to the power of negative 1 plus 2. And from here, dx on dy becomes negative y minus 3 to the power of negative 2, which, if we take the reciprocal of this, it becomes dy on dx equals 1 on negative y minus 3 to the power of negative 2, which this actually becomes dy on dx equals negative y minus 3 to the power of 2. And from here, if we wanted to resubstitute back in, we could. But as you can see, this is one of the examples where resubstituting y as a subject back into here would actually make it much more difficult. So in situations like this, it's often best to leave it as it is here and apply the ideas of calculus from this point forward, which I will demonstrate in the following videos. Okay, so I hope that gave you an insight into utilizing the properties of inverse functions to find the derivative of an inverse. Hope to see you in the next video. Best of luck.